afternoon, everyone. We're going to go ahead and get started. I'm Kate Bailey. I work for Ferguson Bath Kitchen and Lighting Galleries, and we are so pleased to sponsor this session for a few reasons. First of all, we really believe in education within the industry, but furthermore, innovation in design and advancement in technology. And I believe I speak for all of you when I say that Virginia Tech and their FutureHAUS program is certainly dedicated to the things I mentioned before. So I don't want to spend too much of your time, and I certainly don't want to steal Joe's thunder, but I would like to introduce to you today's speaker, Joe Wheeler, who is a professor of architecture and the co-director of the Center for Design Research at Virginia Tech. Joe pursues professional research in environmental and sustainable design, and in speaking with some of his students, he has a great reputation for collaboration and commitment to their education. It's certainly proof of concept, not just the concepts themselves, but bringing them to real life. And I think you'll see that that's what this presentation is all about. So without further ado, I'd like to introduce to you Joe Wheeler.
Oh, there you go. Thank you. So, can everyone hear me okay? This won't be a panel discussion because there's so much to talk about just about the project and the research that we've been doing. I'm going to start by talking a little bit about the bathroom, but then give you a little bit of a background behind what FutureHAUS is, what the program is. I want to start with the sponsors. Usually you end with the sponsors. I want to start with the sponsors because with the university we have lots of talent. We have lots of energy. We have lots of ideas, students that come up with very creative ideas. On the other side, in the industry, you have amazing technology, you have amazing products, but oftentimes you get just people and companies that are just too busy to really explore, the possibilities of what we can do. So we found that by bridging industry and the university, we can do amazing things and we can do fun things. So the bathroom, I'll start with right up the stairs here. So after the presentation, you can go up and get a tour from one of our students. I'm from the School of Architecture plus Design. We have students from architecture, interior design, and industrial design. In addition, we collaborate with the other areas of the whole university. We work with computer science and mechanical engineering, and really whenever we need anything specific, we just go to that department and we bring them on our team. So the university is a great environment to really explore almost anything. The bathroom is smart, it's clean, it's efficient, and it's accessible. Okay. The centerpiece of the bathroom is the smart mirror. It's the interface for the whole bathroom. Our approach to technology is integration, not addition. So when you, just like your iPhone, the technology is just, it's simple, it's easy to use. We don't have to know how the thing works. We just have a really good interface that makes it easy to use and fail-safe. We also look at multimodal kind of operations, different ways. You have manual ways to control things, but then there's also these voice control and gesture control. These are ways to interact with a bathroom that make it easy to use, but also allow possibilities for ideas on aging in place and accessibility, and in general, just good interface. So the smart mirror gives you the information for the bathroom. It gives you information that you need in the beginning of the day, the weather, the time, the daily traffic. It can also then give you data for the bathroom. It gives you if you want to keep track of how much energy you use when you take a shower or when your kid takes a shower, if you want to keep track of how much water you use, we can monitor all that. We have access to controls through the mirror. So when you come in and you're going to turn on your shower, you're not doing this adjustment, this adjustment, this. You go right into your bathroom, you set the temperature, and you go right into the shower. Now, because we have energy efficient systems like the very energy efficient inline water heater, that water is there at the temperature it needs to be right on time. So you're not wasting water waiting for the temperature to be right. The other thing about technology is to take what's out there and integrate it. So one of our great sponsors is Kohler, who was so generous to give us, all of these products, these new technologies that they have that are on the market, and really try and integrate them, beyond just the installation of the appliance. For example, we took the Kohler DTV, the electronic valve system, and we're working with that, modifying, doing whatever we can with that to make it work for, say, instead of the shower, now for the sink. So now on the second kind of category, which is about being clean, it's about eliminating all of the stuff in the bathroom. So now with the DTV, an electronic control of the faucet of your sink, you don't have these extra handles to clean around. It's really easy to use and really easy to interact with. Other ideas on cleanliness is the more joints you have, for example, on a floor, the more bacteria that can build up. So we're looking at, with prefabricated bathrooms, the possibility of having bigger slabs of tile, bigger pieces of floor. In our case, we have one piece of glass. It's a 12-foot wide by 7-foot wide piece of glass, no joints. It's just a beautiful acid etch element design, and Glass Dynamics worked with our team to make this beautiful. So it's a work of art, really, so you can check that out. It's also acid etched for slip resistance. We're integrating technology in the floor. For example, in one location, we have a sensor that's monitoring your weight. So you get your weight projected up on the mirror, if you want that. It also provides, fall detection. So on the side of accessibility, aging in place, if grandma falls in the bathroom, it's detecting that fall, and it can notify the bathroom can notify a caregiver or even 911 if it has to. Or it could just make a simple phone call, say, is everything okay, right? The other thing about being clean is, this is a fun thing, but we can activate the Roomba, the little floor cleaning robot, just by you leaving the room. So with occupancy sensors, vacancy sensors, you can just, certain things can be set up. We integrate a lot of the clutter of the bathroom in the walls, in the cabinets, so that the floor becomes open, becomes clear. Efficient, I was telling you we can monitor energy. We're looking at energy efficient systems to provide hot water. We're looking at low flow fixtures, anything to reduce waste in the bathroom, and accessibility. So the final thing I'll talk about with the bathroom, and then I'll move on to FutureHAUS, is our big idea with the Vanity, with line neck actuators. It's a company that makes actuators for desks, for office furniture. Now we're integrating actuators, and our Vanity can raise and lower. So with biometric ID, which now we have on our iPhones, the touch ID, the fingerprint ID, each individual user of the home can come up to the cabinet, touch the side, it recognizes who that user is, and it presets all of your settings for the bathroom for that user. So for example, my 7-year-old can come in to brush his teeth, he can touch the side of the cabinet, and the Vanity will lower and he can brush his teeth. But there's also presets on music that will come up. Actually, the music comes through our toilet. the Numi toilet. If anything, go and check out the Kohler Numi toilet. It is an amazing piece of art, I would say. And you know, the other thing I like about that is that when have you ever really looked at a toilet as something beautiful in a bathroom? You know, usually it's something that's just you try and, you know, hide away. But this thing, you know, and that's what we're doing with everything in the bathroom. We're trying to elevate everything in the bathroom and make it beautiful. So accessibility also with this vanity that can raise and lower. You can accommodate ADA. You can accommodate a wheelchair. We have the Heavy as the grab bar, which is a removable grab bar, right? So you only need it, you know, when you need it, you can install it. But it's, the structure is pre-installed. So what I teach my students in the area of accessibility is it never should be an afterthought. It's just about smart space planning. Because when you build your home, you want to live in your home your whole life. No one ever wants to have to move out of their house because the house can't accommodate. And so that's what we're doing. Years ago, it's funny, having the booth next to the drill bit sharpeners is kind of, it even bothers us over here. The Lumen House is Virginia Tech's entry into the Solar Decathlon. This was the 2010 Solar Decathlon Europe competition. This house was kind of the third iteration of entering this competition 3 times. This final time, which was the Lumen House, we went to Madrid, Spain. We competed against 19 other universities, mostly German, Spanish, and French, and we beat them. We beat them on energy, we beat them on design, and really we attribute the success of this to the prefab concept. So if you're going to have a smart home, you know, you really have to pre-build it. It has to be built in a controlled environment. And what we're showing with FutureHAUS is that as we expect our homes to be more and more like our phones, and it's, when I say we, it's more or less millennials, you know, the upcoming generations that are starting to expect this to be integrated, we have to rethink how we build. And so what we're doing with FutureHAUS is we're looking at cartridges. We're looking at, you know, pods. We call them cartridges, but prefabricated bathrooms, kitchens, audiovisual walls in living rooms, storage walls in bedrooms, and mechanical, and on and on and on, that are factory built. So instead of, you know, in modular construction, they're shipping big boxes. It's a really dumb way to do things. They're shipping space. We're proposing that you ship technology. You ship just the technology, not the space. And I'll go on, you know, about that. But I'll show you real quickly the Lumen House. It won first place in architecture of the competition, and I attribute that to just good, smart space planning, valuing that in a small, you know, only a 600 square foot space, how important natural light is. We work with Siemens to design a smart home. We call it responsive architecture, where the house responds to the weather conditions, and it maintains complete energy efficiency. So we're using our energy wisely. There's screens for shading, there's screens for insulating, completely automated by the computer, by the control system. The smart space planning allows transformation of the interiors depending on what time of day you're using the space. You know, here, for example, a closet actually becomes a door. This eliminates having to partition a small space up, which makes everything much smaller. Even the photovoltaics, which is a big investment in our home, can raise and lower according to the season, so you get the most bang for your buck out of your investment. Sage glass, which is on the west facade, which automatically tints when the weather demands that. It went to Spain, and you know, there's the Grand Palace in front, and it was successful. Now, how did we get that big house overseas. If we put it on a flatbed, we would have had a real problem because the flatbed puts the house too high and we wouldn't clear bridges. So our innovative team designed a transportation system that allowed a hookup of a gooseneck and a bogie, as front and back, that clipped onto each end of the house, and it allowed the house to move low to the ground, and it allowed us to get on a ship and make it all the way to Madrid like this. Now I call this gift wrapped, right? Because under that plastic shrink wrap is a completely pre-finished house. Now when we got to that site, here we were taking our wrapping off and operating. Here Stuttgart is in front of us, building from scratch the house. And this is when we really learned that, there really is something to getting that technology right and in a controlled environment so that when you go to the site and you operate, it's completely functioning. So because of the success of the transport, even after the competition, we were able to move this thing around. We displayed it on the drill field on our own campus after the competition to kind of celebrate our win. It was on the National Mall in Washington, D.C. It was a month-long exhibition at the National Building Museum on sustainable communities. It was in Times Square in New York City for 3 days on the Good Morning America show. In Millennial Park in Chicago for the USGBC conference. And it even went on and was displayed at the Farnsworth House in Chicago, in Plano, Illinois, for almost a year. The students, the young students were initially inspired by Mies and the Farnsworth House, and that's where the concept really came from. They asked the question, can you have an energy efficient glass house? And so they found out about that, Farnsworth, and invited us. So this is our world. This is my world right now, okay? When I'm giving a lecture, this is what I see. And it's a new generation of people, right? Some of them are out there. The technology is now part of their lives. And there's no getting around it. Their future clients, we have to address that. We have to start making products that deliver this technology. When you look back and you look at how an automobile is made, if you look at how an airplane is made, look at how ships are made, they're in a very controlled environment. They're high-tech objects or devices that you need a lot of quality control on, to produce. And we ask the question, why on earth do we not think about this when we're building houses? You build a house out in the countryside, it's stick-built, it is crude. It is absolutely crude. And then you expect IT guys to come in and install all this technology around the plumbers and around the electrician, around all the tradesmen, and it's just a mess, right? So we're proposing building a house in a factory, or at least in a warehouse. I critiqued the modular building industry. They asked me to write a white paper, a research grant, to critique what they're doing right and what they're doing wrong. And my main comment is they're shipping space. They're not shipping the technology, like I said before. So a couple years ago, actually when we were in Millennial Park, SOM, Skidmore, Owings & Merrill, the partners of SOM, visited us and invited us, our group, to be a kind of a research extension of the Chicago office to propose what a net zero energy medium density housing would look like. So we spent 3 years, summer program, 3 years, working in their offices, developing this, we called it Lakeside. It was a prototype, a proposal for net zero energy housing. And in order to deliver that technology, that high technology you need to have a net zero energy house, we realized we have to deliver it as a prefabricated product. And so out of that, you'll see down below, you get a floor plan that now has eventually become the FutureHAUS floor plan. You can see here that there's a module, a module, a module, a module, a module, a module, module. These all make up 2 3-bedroom units. So we've developed 6-story kind of row houses on down, and now we've latched onto one floor plan and we're building prototypes. The idea is pre-built, prefabricated cartridges are these gray areas. They're pre-built in a factory and they're delivered to the site where these frames are assembled, and then the crane lifts those frames and stacks them. So we've developed 8 cartridges. We get kitchens, living rooms, bathrooms, bedrooms, laundry, utility closets. We pre-wire them, we pre-plumb them, we do everything pre-finish them as much as possible in the warehouse, in the factory, and then they're delivered to the site. Here's our audiovisual wall. I don't know if any of you were here last year, if you noticed, we had the kitchen of the future up in the upper part of the hall. That was our FutureHAUS kitchen. So little by little, we're building every unit to make up that 3-bedroom house. Here's the bedroom unit, which is coming next, which is the 3rd bedroom, which converts into a home office. It's about efficient use of space. Here's the opposite wall of the kitchen, which is the home study and storage. Here's a closet, which can move back and forth between the master bedroom and the kids' bedroom, that can expand and contract depending on what time of year, how many kids are living there, whatever, even if a guest comes over for a temporary visit. Mechanical closets, even looking at prefabricated ceiling assemblies with the lighting, with the ductwork. So what we decided to do, this was before the kitchen was built, was to look at the proof of concept for the cartridge idea. What we're doing is we're going to a CNC manufacturer of SIPS panels, structural insulated wall panels, and we're cutting them with a CNC gantry. So we get absolutely precise frames to build these kitchens and these bathrooms in. I mean, we're measuring to the thousandths of inch. When you assemble these things, they're absolutely square, they're absolutely true, and it's a carpenter's dream, right? Because they're not stepping into a site that has out of square, it's just a mess, right? Here's the kitchen installed. Here is, I'll skip this. Here's the kitchen complete. This project, we're not proposing that all projects are as sophisticated as this. We're just using this model as a proof of concept to test the idea of the ultimate kitchen, right? The Internet of Things kitchen. So in this kitchen, we have the multi-touch screen, a Microsoft multi-touch. Up to 5 users can use this at one time. And it's about not just entertainment, but functionality in the kitchen, researching recipes, Google Maps, entertainment when you have guests coming over for a dinner party. We're working with Corning glass, and we're integrating Gorilla Glass over the top so that it's clean and it's a durable surface, but it still allows you that technology. We have the Backsplash, which is it's a display that integrates everything in the kitchen. So you can turn it on and off appliances. You can monitor cooking. We have a camera in the oven. You can monitor inventory in the fridge, in the pantry. You can even go to the grocery store and pull up your refrigerator and check on your ingredients. All of these are, I'm sorry?
Can you get rid of those panels if that an outside view? I'm just thinking you always have to look at those stages.
Well, it's not a window wall. That's just your backsplash.
So are there any windows?
Yeah, there's lots of windows in the FutureHAUS. They're not virtual windows either. And it's not Microsoft Windows. So here's a concept from the industrial design group for the cooktop. So we're working with shot glass right now, and what we're proposing is that the countertop is one piece of ceramic glass. We're integrating the induction technology under that glass now, so when you're not using the cooktop, you've got an open surface. You've got a clean surface. And because now we're going to work with a universal 2-foot by 3-foot surface, it's wherever you put the pot down, that becomes your work surface. Infrared detection of what's hot, so then you can interact with it and adjust the temperatures. So here's just our prototype was using tempered 3/8 glass, but eventually we're going to lead to a fully functional kitchen. Integrating the downdraft into that technology, we have the Sensate, we have the hands-free on and off, but also gesture control for temperature hot and cold. Here you use the Wii technology, the leap motion, so that everything on the backsplash, you don't want to be putting fingerprints and grease on that backsplash, right? It reads your hands, and you use your hand as a mouse, and you can interact with the screen. The dishwasher detects that actually automatically, the kitchen automatically injects the soap into the dishwasher. When that soap is empty, it can send you a text message. It can let you know when you're out of dishwashing liquid. It sounds crazy, right? That idea sounds crazy, but that led to the slip fall detection we're doing in the bathroom, which sends you a text message if someone falls. So where one idea may sound crazy initially, it may eventually lead to another idea that really makes a lot of sense. Here we have a camera integrated in the oven. Okay, sounds crazy. You can monitor what you're cooking on your phone or in another room. But think about the energy efficiency of the oven now if you can get rid of that glass window, right? The refrigerator, we're monitoring our ingredients. A little scale, a pressure sensor that monitors weight. So it knows when your milk is full, when it's empty. It also knows, because it knew when it was full, it knows what the date of it is. So when you're at the grocery store, you really can go in and check on your milk, your butter, your eggs, and whatever, yogurt, whatever else you want to monitor. Not everything, but a few things. We now are using that technology with the bathroom that's monitoring your shampoo, your gel, and your conditioner. And so now it's not alerting you, it's not sending you the text message, it's actually alerting Amazon Prime with the Prime button, and the order of the new shampoo comes, 2-day free delivery. The pantry does the same thing. So we're monitoring your stock ingredients, your flour, your sugar. Eventually, this isn't something that's added. I'm proposing that this is something that the Kesselboomer, the manufacturer of the pantry, they're going to grab onto this, and they'll eventually make pantries that are smart. Whirlpool, Genair, they're going to grab hold of this idea, and they're just going to integrate it into the fridge, into the refrigerator. I don't think it's going to be anything that really raises the cost of what we're doing. I think it's just the evolution of the appliances and where they're going. Microwaves drive me crazy. The interface for the microwave has always been horrible. Whoever reads a manual on a microwave to figure out what all those buttons are for? And when it comes down to it, really you end up only using one button, the add 30 seconds button, right? So the microwave, I actually spoke to the Microwave Institute of whatever in San Diego about, to their designers to say, look closer at your interfaces. Now, on your Backsplash, you can actually go to the microwave. You can actually take what you're cooking, say if it's I don't eat TV dinners, but you put it in there, it scans as it goes in, and it presets the time. What we did with the microwave is we actually installed an infrared sensor that's actually monitoring the temperature of what you're cooking, so it turns off when it's done. Say if you're boiling water, it turns off when the water boils, so it's not a guessing game on time. We also have a microphone installed, so we're listening for when you're cooking popcorn. When popcorn's finished, it turns off. Now this comes from the students being kicked out of the dorm rooms in the middle of the night, right? Everything we can possibly do to kind of rethink what we're doing in a kitchen. That's what we did with this project. So now we're looking at whole house interfaces. Is there something that happens in the bedroom that signals something that happened in another room? So as a proof of concept for that, we're monitoring the shower temperature of the water in the morning. Between 6 and 9 a.m., the temperature of the shower head changes, it activates the coffee maker. Crazy ideas, but can they lead to something? Will they lead to something? Hey Flora is a big sponsor, Plain and Fancy Cabinets, Bloom. We're working with all these cabinet and hardware guys to just make the user-friendly kitchen. Touch to open, everything, easy to use. Now we have concepts for the kitchen, like we're actuating the Vanity, where you can actuate cabinets so they're easily accessible. Upper cabinets, wall cabinets. So here we were last year, and that's how we packed up. It's really beautiful and simple. All of the technology is pre-installed, all the finishes are pre-done, a wall folds up, and you protect it for shipping. You don't have to open that up until it's installed, until punch list day on the site. So we're proposing a slab is poured, cartridges are brought in, all the technology is there, you don't have any tradesmen on top of each other, then the house is built around it, stick framed around it. And then you use your stick framing as your chases to tie everything together. The next step was a living room. It involved 3 cartridges. One was a doorway, a door entryway, and 2 opposite sides of a living room. Here we were in Atlanta last year exhibiting facial recognition to open the door. It's a very secure way. You don't have to fumble with keys. You approach your door, it recognizes your face, and it opens the door for you. You're carrying groceries, whatever, but it's very secure. You can see who's there. Someone rings the doorbell. On all your displays, you can see who's at the door. When you're at the grocery store and someone rings your doorbell, you can see who's at your door. You can actually let them in if you want to. So the living room was about lighting. It was this is work with Philips Color Kinetics. This is tech lighting. This is installing many different types of light, and the smart home detects what's happening in the house and then adjusts the lighting accordingly. So if the seat sensors detect that there's one person there, as one person is reading a book, you're going to get a warm task lighting locating, spotting you at your seat. If the vacuum is running, you're going to get overall really bright, cool light for cleaning. We've got a grant through the university to explore lighting and the psychology of light and the comfort of light. So that a lot of different research projects tied together on this whole. We're working with DuPont on the development of new building materials for prefab projects. This involves working with the chemistry department, and they're looking at a new product to kind of improve Tyvek, for example, for modular construction. DuPont, we're working with Corian. We're looking at the Corian as wall surfaces. Now that solid surfacing material, there's so much competition with composite stone that they're looking for other alternative ways to use the product. We're working with Interlam. We're using Interlam's product because they figured out how to cast the Corian material, the marble dust, into thin sheets. And so if you look at our bathroom, we have the bathroom stall made with this product. Even rethinking how you Skype, because no one likes to Skype like this. Skype is something, it's like inviting someone into your living room and having a casual conversation with someone. Just we're thinking of everything, but that whole living room and kitchen now packs up like this. So now we're moving this whole house on one flatbed truck. So 2'6" panels stacked side by side. That makes your 8-foot width of a flatbed, 3 deep, and you have 9 cartridges on one truck without any oversized loads. A lot better than what the modular guys are doing. Eventually, all of these pieces that we've been building are going to come together and be the FutureHAUS that we're going to fabricate on campus. We're going to assemble this in our research park, and it will be kind of an exhibition space for really the house of the future. One floor is going to be all about aging in place. You're supposed to walk through this and not even know that this is an accessible plant, right? It's just going to be so well integrated. The other is the smart home, right? We're working on energy, performance, integrating photovoltaics, integrating renewable energy, everything, and on, like kind of what you've been seeing. Now, eventually, one other thing that we've led, it's kind of a road we're going down, is the use of new technology to visualize products. So if you start thinking of prefabricated homes, so factory-built homes, how do you visualize them? How do you sell the products? And we're seeing a great opportunity with Oculus Rift. So eventually, you'll see us here. You're going to see the Virginia Tech booth at KBIS, and it's just going to be an empty floor. The idea is you just put on the goggles. It's augmented virtual reality, and you'll be able to walk through, but not just walk through and see the design. You can walk through and interact with it. So you can click on the cabinet, the countertop, and you can actually toggle through different options for the countertop. You can change the furniture. You can change the wallpaper. You can change the lighting. And the idea is the designer will walk through the house with the client. You can design your space, and that work order goes right to the assembly plant where that cartridge is made. Proof of concept for this idea, okay? This is a reaction to last year, someone approaching us with the kitchen and saying, you academics, they said, here you are proposing something that no one could afford. And I said, no, you're missing the point. The cartridge idea is a vehicle for building a building, whether it's affordable or expensive. It really, really works. And so this summer, myself and a few of my past students, we went in on a construction loan, and we found a site in Charlottesville, Virginia, and we built a 2,200 square foot house. We built it in a summer. It involved 2 floor plans, 12 cartridges. The light blue are the cartridges, 2 floors. Okay, we built these cartridges in a little warehouse. Amazingly wonderful to be in an enclosed environment with, and many times, air conditioning, right? To be working on the kitchen, the living room, the bedroom, walls. We assembled all 13, and we brought them in one day, in an 8-hour period, with a crane, and we set them on the slab. All 12 cartridges went in. Within 8 hours, and it was beautiful. We could have even developed these cartridges more, but the bank kind of wouldn't release our loan money until the actual product was delivered to the actual site. So that was one little hiccup. So we're going to it's going to take some working. So this is the point we got to after 8 hours. So that morning it was just a slab. The building was closed in, the interiors were protected, and 3 months later we had the complete house, the finished house. The house was sold for profit 1 month before it was even built. And it was really built by a small group of people, basically three people, myself and 2 others. But you can see on the interiors, cartridge and then infill. Cartridge, inner layer. Cartridge in the bedroom, pre-installed cabinets, pre-finished wood interiors. The bathroom, pre-tiled, pre-plumbed. All the electrical, lighting, vents, everything was pre-installed. You see the kitchen wall, we installed them with the appliances in place. So this was in Charlottesville, Virginia. And it was efficient then. It was efficient, but having done it one time now, we've come up with many more ideas on how to make it more efficient. So in the future, you'll see not just new houses by our crew, by our team, but new cartridges. That's Virginia Tech's motto, inventing the future. and we're doing it with our partners. So, Barbara, where are you? I'll end this presentation with a little bit of humor. Do we have sound on the computer? Yeah, there you go. My last year has been crazy because we went from inventing the kitchen and building the kitchen, coming to KBIS, doing the living room, going to AIA convention in Atlanta, building the house over the summer, and then building the bathroom for this show. So my little boy, 7 years old, was with me the whole time, and he started kind of catching the fever on invention. Like he's a little inventor himself. And he asked me, he says, Daddy, are you ever going to build my invention? I said, what is that? And he said, it's the food gun. It's the food gun for the kitchen. So it goes along with some of these crazy ideas we're coming up with and engaging. But I want to end it with my 7-year-old and his explanation. Can you control volume on this?
Hi, I'm Cyrus, and food guns are kind of cool. Like, they come out of the ceiling here, and they just come down and pretend there's just a plate right here. And that food gun came out of there, and you don't have to just walk to the kitchen like you don't have to walk to the kitchen and gather food and go to the grocery store. It just comes down and shoots food onto your plate.
Like father, like son, right? They're crazy ideas. So I'm finished. If there are any questions, I'm happy to answer them. They love it. Okay, initially the building inspector came into the warehouse where we were building all the cartridges. He said, you're crazy. He said, this is crazy, just stick build it. You're doing all this extra work for nothing. 3 months later, when these things were on the site and they were all starting to come together, he was sold. He loved it, and he started bringing his entire crew out. He says, I want you guys to look at this because this may be the way we build in the future. They agreed to come. I mean, this took some flexibility with them, but they came and pre-inspected in the warehouse. Yeah. Is it on, the mic? Okay. Anyone else?
What was your budget for that house?
We built it with the land for $350. We sold it for $450. Then we made a profit. And that was the first time, so I know we can fine tune it too.
So I was going to ask before, did you discuss anything about pricing, about the panels or anything like that? I came a little late, that's why I was asking.
We haven't even gone there, but it's our next step. We're talking with some cabinet companies, Victor over there. Thinking, what if we now did a trial? What if we did a trial where we had a cabinet manufacturer actually make a cartridge and price it all out, come up with a price, and then we partner with a builder and have that builder build a prototype and track that price as a research experiment to see if this is truly a viable way. We're not sure, but I really believe after working on it more and more that it is a viable way to do it. I'm sorry?
The house that you sold, the one that you built
Yeah.
and then sold, it must have been commercially viable in that area or...
Yeah, well, the reason we went to Charlottesville is we did our market analysis. We looked at what we could sell a 2,200 square foot house at, and if it matched. So we couldn't have built this in Blacksburg, because the market, 250 maybe would be what we could have sold it for. But Charlottesville was a prime market. The closer you get to DC, the better.
So comparable to a house in that area, like just a normal
Yeah.
house in the same square footage, the same...
Yeah.
Was it comparable? Was it around the same?
That's where our market price, that's where our sale
What's that?
price came. I told my partners we shouldn't pre-sell it. I mean, we shouldn't pre-sell it. We should wait and probably wait on a bidding war for it, because I think you really could have gotten more for it. It was a custom home. There's not much drywall in there. It's pre-finished wood panels, and it's a really custom design. So,
Plumbing, I would think, or anything that, I guess that module creates its own energy completely? What
No,
do they want to get?
not
No?
this.
Okay.
this has nothing to do with energy right now, except
solar, okay.
except the infiltration rate. I mean, it was we did the blower door test, and it performed beautifully, better than the inspector, any house that he's done in Charlottesville. And it's because it SIPs panels. It was a really tight envelope with good insulation.
So you still had the plumbers come in and the electricians come in and...
They still come into the site, but they just tie everything together. And you don't lose your trade. You don't lose your designer. You still have the designers. You don't lose your tradesmen. They're just doing the work in a much better environment.
Okay, good.
Okay? We good? Thank you very much.